So we're going to define all this stuff of a circle. Like I said, some of this you already know, but we just haven't really defined it yet. Like, you already know what a circle is, we just haven't defined it. A circle is the set of all points in a plane equidistant from a given point. And if you want, you can use your compass to draw yourself a diagram. Circle. So all the points are equidistant from a given point, that given point being the center. A radius, again, we've already talked about. Oh, sometimes you'll see in the book, like if I put a D there, in the book they'll sometimes use like a circle. They'll say circle with a dot and then they'll say D. They're talking about circle D, especially if it gets confusing with like if there's like a bunch of circles in a diagram. A radius we've used already, but we've never defined it. It's a segment whose endpoints are the center and any point on the circle. So if you draw yourself a circle, the radius is from the center out. We've been dealing with that before when we did pi r squared to pi r. We always had a radius. Okay, the next word is chord. It's a new one. We haven't seen it before. A chord is still a segment. It's a segment whose endpoints are points on the circle. So a chord, the endpoints are on the circle, but they don't necessarily have to go through the center of the circle. So it's any segment in the circle, but the endpoints doesn't necessarily have to go through the center. So that's a chord. It just kind of goes within the circle. We're going to talk about chords more in this section of the notes, like today and Wednesday and Friday. A diameter is a special kind of chord. And we've already done diameter, but we haven't defined it. A diameter is a chord that goes through the center. So a chord is any segment, doesn't necessarily have to go through the center. A diameter is a special kind of chord. So it's endpoints of the circle and has to go through the center. A tangent and secant. Tangent's different than tan of our SOHCAHTOA. A tangent of a circle is a line that intersects a circle at exactly one point. You know how people say they go off on a tangent? It's because they start at one place and then they veer. That's kind of like what a tangent does to a circle. it's a line that touches the circle at just one point. And the point where it touches is called the point of tangency. Think about if somebody says, I just went off on a tangent. They went and veered at one particular point. And then a secant, kind of like a tangent, except it intersects the circle at 2 points. So a line that intersects a circle at 2 points. So a secant is just a chord that's a line. And again, it doesn't necessarily have to go through the center. So when you're looking at these definitions, 3 of them are segments, 2 of them are lines. So when you're trying to match, you want to look at the top. That will help you. A radius is a segment. A chord is a segment. A diameter is a segment, meaning it stops. All 3 of those stop at the edge of the circle. A tangent and a secant are lines. And that's kind of how I remember the difference. So a secant is just a chord that's a line. Okay. So, example 1 says, tell whether the line, ray, or segment is best described as a radius, a chord, a diameter, a secant, or a tangent for circle C. So, A is segment BC. Segment BC, what do you think it is? Radius. B is line EA. Line EA. What do you think? Secant, good, because it hits the circle at 2 different points. Okay, this was a segment, this was a line. Line DE. Tangent, because it only hits at 1 point. You should grab the review. It says quiz 1 review. Segment FA. Chord. Segment AB. So again, this was a line, segment, segment. So we just got to get through some vocab first. On the next page, there's a bigger picture. The only thing I want to talk to you about, or I'm going to have you do this on your own, common external tangent, common internal tangent. Common external tangent means the line is outside the 2 circles. It hits 2 circles both at the outside. Common internal tangent, it should be in between the 2 circles. So take a second, see if you can match 1 through 8 with the vocab words. So number 1 should have been E, point of tangency. 2 was G, a common internal tangent. Do you see how it's FH? See how it goes through the 2 circles? That's why it's internal, because it goes in between. 3 was D, it was a radius. 4 was B, it was a chord. 5 was A, it's a center. Anytime it's a point, it's either a center or a point of tangency. Those are your only 2 points. 6 was C, it was a diameter. 7 was H, it was a secant. And then 8 was F in external tangent, because you see how it's on the outside of the two circles. Okay, so the first part of your quiz next week will be vocab, just like this. And that's the first part of your homework, too. Okay, so we got to look at tangent and radius. So everybody take your compass that's on your desk and draw a circle. Now, I just pick, it doesn't matter how big it is. I mean, I just use one of the dots on the inside here. Plus, it's a lot easier to move. So just draw yourself a circle. And put a dot at the center. If you put your pen in there. The center is going to be point P. And what we're going to do is we're going to create a tangent line. We're going to create a tangent line. So what you want to do is pick a point on the circle, and we're going to name that point T, and I'm going to connect P to T. So this is a radius, right? P to T would be a radius. Now, I can create a tangent at T. Try to take your compass where this and make a straight line, only touching the circle at point T. So don't go sideways. You only really want to touch the circle at point T. What happens is whenever you have whenever you have a tangent and a radius, they end up making a right angle. This ends up being a 90-degree angle right here. So the radius and a tangent line are perpendicular with each other. So any radius and any tangent line will create a right angle. What we're going to do is we're going to use this and use what we learned in chapter 7 to find different radii. So that's kind of what's down here. In a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius at its endpoint on the circle. So if you can create a right angle, then you know that line's a tangent line. Otherwise, it's a secant. It's just really close together. So the first thing, if I'm looking at example 3a, it says, determine whether ST is the tangent line to circle R. What we're going to do is we're going to use Pythagorean Theorem. Because Pythagorean Theorem gives me a right triangle, which means there's a right angle. So what I'm going to do, what we want to create the right angle is going to be, again, with the radius to the tangent line here. So we're going to check, is a squared plus b squared equal to c squared? Now in the first picture, you have s to r is 12, you have s to t is 16. That 7 is really only from the circle out. But how big is it from the circle to r here? This 7 only starts here and goes out. What is this, you think? 12, because it's still a radius. So this whole side together is 19. So if they just give you a number and it looks small, because that should be the hypotenuse technically, it's because they didn't add in the radius part. So we're going to check. Is 12 squared plus 16 squared, what is that with 19 squared? If it's equal, we got a tangent line. If it's not equal, we got no tangent line. So 12 squared plus 16 squared gives me 400. 19 squared is 361. So those are not equal. So ST is not a tangent to circle R. B, they helped us out a little bit. They gave us all three sides. T to R is 26. We don't have to add to it because that's what this bracket is. So let's check. Is 10 squared plus 24 squared, what is that with 26 squared? This is 676. 676, thank you. So these are equal. So now we can say yes, ST is a tangent of circle R. Okay, the last thing we gotta do is the hardest part. We can use this same property, this same theorem, and we can figure out how big a radius is in a circle if you're given certain other information. Okay, the tricky part here is the algebra. So we're going to stick with that, should be an R. We're going to stick with the fact that in the diagram, B is a point of tangency. We want to find the radius. So B is where there's a right angle. And then we're going to stick with Pythagorean Theorem to help us find R. So here, the Pythagorean Theorem, this BC is A, BA is B, and then this whole thing's C. So we got to figure out, it's going to be R squared plus 77 squared equals R plus 49 squared. Because that third side is the radius plus 49. Here's the tricky part. This square, well, what's R squared is R squared. What's 77 squared? $5,929. The tricky part here is this is not just R squared plus 49 squared. This you got to FOIL. You remember foiling? Algebra 1? You got to remember R plus 49 squared is R plus 49 times R plus 49. You can't just square both things and call it a day. That's where everybody screws up. We're going to have to FOIL this. You guys remember foiling? What do you do first in the foiling? What's R times R? R squared. What's R times 49? That's the outside. 49R. Oops, that's a bad R. Then we got to do the inside. Then we got to do the last. I don't know what 49 times 49 is. 2,401. So you have to FOIL. First outside, inside, last. So this turns into R squared plus 98R plus 2,401. If you just do R squared plus 49 squared, you miss this, and you don't know, you can't answer the question. In order to solve for R, do you see how R squared is on both sides? Remember when we talked about if pi was on both sides, you could just cancel it? Same thing works for r squared. Since it's on both sides, we can just cancel those out. And we get 5,929 is 98r plus 2,401. If you don't FOIL this one side, the 98r is not there, and you end up with two numbers. And you can't solve. So what should I do to solve for r next? How would I get it along? Subtract. $3,528 equals 98r. And then what's my last step? Yeah, divide by 98. So the radius here is 36. Okay, so the hardest part is foiling. It's algebra skill that you got to remember from last year. Okay, let's try another one. This takes some getting used to, but we're going to do a lot of these problems before your quiz next Wednesday. So, you're trying to figure out B is the point of tangency. You're trying to figure out the radius. So here you're going to have r squared plus 15 squared equals r plus 9 squared. And depending on who you had for Algebra 1, you can think about this as a pattern, or you can just do FOIL. I don't know what's happening. So you can either FOIL it or think about it as a pattern. I just FOIL. So we'll end up with r squared plus 15 squared is 225. And then I'm going to write this out like, I just kind of get rid of this and go r plus 9 times r plus 9. So what's r times r? R times 9? 9 times r? 9 times 9.
81.
Here we go. So then you can do two steps at once. The r squared should always cancel. And we'll get 225 equals, I can add the two 9r's together. 18r plus 81. Once you get to know this kind of problem, the process is the same. So then subtract 81. $144 equals 18r. And then divide by 18. So you get r is 8. Again, the hardest part is the FOILing. Questions?